Hi everyone, and welcome to the VUMA-network training video. My name is Jenny, and in this video, I'll be going over the basics of navigating a VUMA model, as well as creating and editing branches. We will start off by loading the first example model, called Massive Mine with Pit. Chapter 1, Basic Navigation. To start, let's look at how to zoom in and out of a model. You can use the mouse wheel to zoom in and out, or you can use the plus or minus keys on the numpad. Note that VUMA zooms into where the mouse cursor is positioned. To pan or move around the model, you can hold down the mouse scroll wheel, also referred to as the middle mouse button, and move the mouse. You can also set the pan mode to the left mouse button by clicking on the pan mode button on top. To rotate the view, hold down the right mouse button and move the mouse. Rotation works best if you have either a branch or a node selected before you rotate. If the model does jump, you can undo the sudden view change by tapping the backspace keyboard button. To fit the entire model on the screen, click on the Zoom Fit button on the left view panel. If you want to go to a specific branch or node, use the Find option by clicking on the Find button on the main toolbar. To toggle the visibility of a VUMA-network element, you can use the View panel on the left-hand side of the screen. Simply check or uncheck the item in question. For instance, you can toggle the visibility of excluded branches or nodes. You can also change some settings directly from here, like the node sizes. Alternatively, you can make use of the View menu to toggle and edit the display settings. To change the coloring of the model, set the type, and then the property by which you wish to color by. Options include airflow, heat, contaminants, and more. To set the text of the model, first toggle the display text to a checked state, and then set the type and associated property. Options again include airflow, heat, contaminants, and more. Sticky text is useful to limit the amount of text rendered. Rather than showing text on each branch or node, you can specify which branches to display text by accessing its context menu, right-clicking, and setting or clearing its sticky text property. Once you have one or more branches with sticky text, you can enable the sticky text button, and then select which property you want to display. You can use the custom field to select more than one attribute. For instance, you can show the branch name, temperature, and velocity values. Additional sticky text options can be found under the View menu. Here, you will also find a link to the new list view, which keeps a record of all the sticky text branches and updates automatically after each solution. Chapter 2, Branch Types. VUMA-network allows a mine network to be built up by linking numerous component elements, each with specific aerodynamic, thermodynamic, and contaminant characteristics. The basic component elements, called branches, comprise of shafts, tunnels, development headings, stopes, fans, and control manager elements, which include air coolers and regulators. To create or draw a new branch, select the type of branch you want to create from the pencil drop-down on the main toolbar. Then, left-click on the canvas to start drawing the branch. To end the construction, left-click once more. To edit a branch, double-click on the branch. Alternatively, you can edit it via the right-click context menu, or hovering over it and pressing E on the keyboard. The first branch type is a tunnel. Tunnels are the most common type of branch, and they're used to connect different parts of the mine. To create a tunnel, you'll need to select the tunnel type from the toolbar. Then, click and drag to draw the tunnel. Once you've drawn the tunnel, you'll need to specify some information about it, such as the air type, frictional resistance, as well as dimensions. You can also add subdata to the tunnel, such as heat loads or contaminant sources. Shafts are another type of branch that's commonly used in VUMA-network. Shafts are vertical tunnels that connect the surface to the underground levels. To create a shaft, you'll need to select the shaft type from the toolbar. Then, click and drag to draw the shaft. Once you've drawn the shaft, you'll need to specify some information about it, such as the diameter and wetness. Development headings are used to simulate the excavation of tunnels in virgin ground. They're typically used for exploration or for the establishment of new production zones. To create a development heading, you'll need to select the development heading type from the toolbar. Then, click and drag to draw the development heading. Once you've drawn the development heading, you'll need to specify some information about it, such as the air type, the length, and the face advance rate. Fans are used to move air through the mine. They can be either axial flow fans or centrifugal fans. To create a fan, you'll need to select the fan type from the toolbar. Then, click and drag to draw the fan. Once you've drawn the fan, you'll need to specify some information about it, such as the fan curve, the air type, and the layout configuration, for instance, 2 fans in parallel. Control managers can be used to control the flow of air through the mine. For instance, to regulate the flow by increasing pressure like a fan or by destroying pressure like a regulator or seal. Control managers can also add heat, for instance, a substation or a hoist, or add cooling like a bulk air cooler or cooling car. To create a control manager, you'll need to select the control manager type from the toolbar. Then, click and drag to draw the control manager. Once you've drawn the control manager, you'll need to specify some information about it, such as the type of control manager and the air type. Production zones, or stopes, are branches that represent areas of an underground mine where the ore is produced or minerals are extracted. VUMA-network allows for a wide range of mining methodologies, including narrow reef, massive ore bodies, and colliery layouts with different levels of mechanization and backfill. To create a production zone, you'll need to select the production zone type from the toolbar. Then, click and drag to draw the production zone. Once you've drawn the production zone, you'll need to specify some information about it, such as the mining type, the dimensions of the excavation, and the thermal attributes. The mining type determines the way the production zone is modeled. There are 8 basic production zone types to choose from, each with its own set of parameters. The dimensions of the excavation determine the size of the production zone. You can change the dimensions of the excavation at any time, and VUMA-network will automatically update the tonnage. The thermal attributes determine the heat load from the production zone. You can add additional thermal attributes on the Thermo tab. During solving, VUMA-network will calculate both the face condition and the reject condition. The face condition is the condition of the air at the face of the production zone. The reject condition is the condition of the air that is rejected from the production zone. Note that the display size of stope branches can be toggled using the View Realistic Stope Sizes button. Chapter 3: Levels and Layers. Levels are used to group branches of a similar depth. This can be useful for organizing your model and for making it easier to visualize the flow of air. To create a level, go to the Level Editor by going to the Display toolbar and then clicking on the Editor button on the Level tab. Inside the Level Editor, you can add, edit, or delete levels. You can also specify the color of each level. Once you have closed the Level Editor, you can toggle the visibility of levels using the checkboxes in the last column. You can make use of the icons on top to highlight a specific level or to color the model according to the level colors. A quick alternative to adding levels is to highlight a node and, from its right-click context menu, choose Add New Level. Unless a level already exists, you will be prompted to set the level name. Next up, layers. Use the Layer Editor to create or delete new layers. Layers are like levels, but they are user-assigned to a branch and not automatically according to depth, as is the case with levels. As with levels, you can toggle the visibility by checking or unchecking the last column. You can also make use of the icons on top to highlight a specific layer or to color the model according to the various layer colors. Chapter 4: Global and Branch Defaults. To set the global defaults, go to Libraries, Global Settings, and enter the values corresponding to your mine's ambient conditions. These values are very important, as they determine the mine's inlet conditions. You might need to have two sets of data, one for peak summer and one for peak winter conditions. Also pay special attention to the rock and geothermal gradients, as their resulting VRT values will greatly influence the mine's heat loads. To set a branch default, click on the Settings Branch Defaults button, and then choose the branch type to configure. For this example, we will select the fan option. Once the fan form has opened, choose the default library fan that will be used most often. You can also configure the default layer and air type. Click on OK to close the form. When a new fan branch is drawn, it will have the properties of the default fan. Note that changing defaults will not affect or modify any existing branch, but will only be applied to branches created thereafter. You can also set a default by first editing a branch, and then clicking on the Set as New Default button. Chapter 5: Construction Tools, Part 1. These tools can all be accessed from the main toolbar at the top of the screen. Before we start, let us reload the massive mine with pit example model. The first tool is the Delete tool. To activate this tool, click on the eraser icon. Clicking on any branch will now delete that branch. Nodes cannot be deleted, but they will disappear automatically if they are no longer attached to any branch. To exit the delete mode, press the Escape button or click Select from the right-click context menu. Now, let us look at the Format Painter tool. This tool is used to copy specific, or all, of the properties between branches. To use it, first, click on the Format Painter button. Select which properties you wish to copy. You can also toggle the Color Assist mode on or off, which in turn will show you a visual representation of the branches whose properties are being replaced. Click on OK to close the form. Start off by clicking on the branch from which you want to copy the properties. Then proceed to click on the branches where you want to override properties. The chosen properties from the first branch will be applied to the second branch. To exit the Format Painter mode, press the Escape button. The Merge Mode tool is to the right of the Format Painter tool. It allows you to quickly merge two connected branches into a single branch. To use the Merge Mode tool, first click on the icon. Then, click on the two branches that you want to merge. The branches must be connected at a node. The properties of the first selected branch will be used for the merged branch. The second branch will be deleted. If you try to merge two branches that are not connected, nothing will happen. If you try to merge two branches of different types, you will be prompted first. The next tool is the Magnet. The Magnet tool lets you quickly connect branches. Upon magnet activation, the initially chosen branch remains stationary. However, the nearest node of the second selected branch, with respect to your click on the first branch, will connect to the closest node where you initially clicked on the first branch. The opposite of connecting will be disconnecting. To disconnect a branch, right-click on the branch where you want to disconnect, and from the context menu, choose the Disconnect option. A new node will appear where the mouse cursor was positioned. You can also use the shortcut Ctrl+D to disconnect a branch. Chapter 6: Construction Tools, Part 2. The Branch Picker tool is up next. The picker allows you to individually add or remove branches from the multi-selection set. This is useful when the normal rectangular or fence selection is not quite suitable, or if you want to fine-tune the selection. To use the Branch Picker tool, first click on its icon. Then, click on the branches that you want to add to the multi-selection. You can also hold down the Shift key while clicking on branches to add them to the selection without activating the picker mode first. Note that the branch hints will update as you modify the selection with summary information. To remove a branch from the selection, click on the branch while the branch picker tool is active. To exit the branch picker tool, press the Escape button. You can also clear the entire selection by pressing the Escape key a second time. The Insert Default Control Manager tool sits next to the branch picker. It is very useful for quickly adding a control manager to an existing branch. This can be done without disconnecting and rejoining the nodes manually. To use the Insert Default Control Manager tool, first, define the default control manager, which might be a ventilation door or some other type of regulator. Once you've defined the control manager, click on the Insert Default Control Manager icon. Now click on the branch or branches where you want to insert the control branch. The control manager will be added to the selected branch. Chapter 7: Other Construction Tools. Now for a quick look at some of the other useful construction tools that you can find on the right-click context menu. Change branch type. This allows you to change the type of a branch, for instance, changing a control manager into a fan or changing a development end into a tunnel. Change flow direction. This allows you to change the flow direction of a branch. Flow directions are especially important in the case of a fan or a fixed flow. You can toggle the visibility of the drawn direction using the relevant icon on the left of the screen or using the shortcut A. The segment option allows you to split a branch into shorter sections. You can either split the branch by a predefined length or by its development age. To use the segment option, first click on the icon. Then, specify the length or age of the segments. Once you've specified the segment criteria, click on OK. The branch will be segmented. The Select Similar option is a powerful tool that allows you to quickly select a group of branches by their matching properties. You can select one or more properties to fine-tune the selection. As you check or uncheck options, the selected branch count will update. Note that some options are only relevant to certain branch types, such as library fans or production status. The split branch option is useful for breaking up longer sections of branches. Splitting branches will duplicate the existing subdata. So, if you had a vehicle in the original branch, you would now have two of the same vehicles after the split event. It is often easier to use the shortcut to better position the split. In this case, the shortcut is the letter S. Chapter 8: Adding ducts for secondary ventilation. To ventilate development or dead ends, you will need to add columns to your ventilation network. Ducting can easily be added to existing branches by entering the Add Duct mode. To achieve this, select the Add Duct mode from the pencil drop-down or use the shortcut J. On the ducting form, configure the duct's name, size, layers, friction, etc. Click on OK, and then proceed to click on all the branches where you want to add ducts. The duct will be added to the branches. You will need to change at least one of the duct branches to either a fan or fixed flow in order to force or exhaust air through the column. Depending on your settings, leakage branches might be added automatically. You may need to alter their respective resistance values for a higher or lower amount of leakage. Make sure that you do not overconstrain the column by having only a leakage branch at the end of the column. Rather use the Format Painter to overwrite the last connecting branch to the same properties as the duct. You can make use of the Air Types page to show or hide all the ducting branches. Similarly, you can also show or hide other specific air types, such as intake or return air branches. Ducts can also be added to a multi-selection by first creating a multi-selection, and then using the Add Ducting from the context menu drop-down. Chapter 9: VUMA Reporter. The VUMA Reporter is a powerful mass editor and viewer. It is divided into three main sections. Section 1: Inputs. This section contains all the inputs of the model. You can easily sort or filter the inputs using the column headers. You can also customize which columns to view. To edit a value or values, select the required inputs and right-click. Proceed to enter the new values and then click on OK. Only a single column can be edited at a time. Section 2, Outputs. This section contains all the branch or node results. Output values can be sorted or filtered but not modified directly. Notice that a few summary values are displayed at the bottom of the screen, reflecting the aggregate value of the currently selected cells. Section 3, Summaries. This section contains several summaries of the model data. Click through the various output elements to familiarize yourself with the available content. Summary values are dependent on the last solve, so ensure that your model has converged before reporting on any of the values. Note also that the heat from branches marked as dedicated return airways are intentionally excluded from many of the summary totals. Now for a couple of quick tips on using the reporter effectively. Double-clicking on a branch or node name will zoom to that element in the 3D model screen. You can limit the reporter's dataset by first multi-selecting some branches and then launching the reporter. When the prompt pops up, answer yes to limit the reporter's dataset. This can be very useful for drill-down reporting or editing. Once inside the reporter, you can toggle whether you wish to include all the excluded branches in the report. Data from the reporter can be exported to other programs, such as Excel, either by a simple copy and paste or via the CSV export option. You can also perform a solve from inside the reporter. Chapter 10, Reference Drawings. VUMA can import and convert mine plans from a variety of third-party software vendors, including AutoCAD, MicroStation, and Deswick. As a demonstration, let's import an AutoCAD drawing together. Open a new blank model, then click on the File, Import Reference Drawing option. You will be prompted to choose the file first, so browse to the example folder located inside the VUMA installation path. This is typically on the C drive inside the Program Files folder. Once there, load the AutoCAD example model and click on OK. With the model loaded, you can now remove layers from the drawing or even delete blocks by first fencing them and then pressing the Delete key on the keyboard. Once you are done with the cleanup, click on the File, Load in VUMA button to return the model to VUMA. After the drawing appears in VUMA, you will probably want to convert the drawing into equivalent branches. To do this, select the required drawing or required reference layers and click on the Convert button. Set your preferences on the next screen and click on OK to continue. Depending on the source drawing, especially if it was not centerlines, you might have to do some further cleanup post-conversion. To speed up the process, look at the Streamline Model options under the Tools section. Chapter 11, Calculators. VUMA has a few calculators that can be used for specific applications. These calculators are located under the Tools, Calculators menu item. Psychrometric calculator. This calculator can be used to determine the air, or psychrometric, properties based on a combination of input values. The results can be copied to the clipboard. Next, the air cooler calculator. This calculator is useful in designing a bulk air cooler. Enter the air and liquid side parameters, and then specify a cooler type. Click on Solve to show the results on both the graph and the associated data table. Air cooling power calculator. This calculator provides information regarding the air cooling power and its limiting skin temperature based on the worker's working condition and clothing rating. This calculator can be used for both acclimatized and unacclimatized workers. Mixing calculator. This is a handy tool to help with determining the condition of a mixed airstream, i.e., where multiple airstreams join. You can have up to 4 streams mixing. Conveyor calculator. this calculator uses simplified inputs with a rule-of-thumb approach to calculate a heating value from both the motors of a conveyor and, optionally, the heat from the broken rock as transported by the belt. The calculated heat can be carried across to VUMA as an equivalent dry linear user heat. Chapter 12, VUMA Solver. There are two options for running a flow simulation in the solver, namely an aero and a full solve. During an aero solve, the node temperature will not be adjusted according to the heat in the mine. This is useful to verify that the model is solvable and a solution can be obtained much quicker than a full solve. During a full solve, the node temperatures will be adjusted for the heat generated in the mine. This is a much more precise simulation but will require more time to solve than the aero solve. When you solve a model in VUMA, you may receive warnings or errors. Warnings are not fatal, but they may indicate that there is a problem with your model. Errors will prevent the model from fully solving. Several options may be set for the simulation, such as the number of iterations and acceptable error. To access these options, click on Solver Settings menu item. This will open the Solver Parameters window. A useful option here is the Reset to Initial Settings, which will reset the solving parameters to default values. The maximum number of iterations edit box sets the maximum number of iterations that will be performed for the simulation. When the Do Fixed Number of Iterations drop-down box is set to true, this is the number of iterations that will be performed. If it is set to false, the simulation will use the error settings together with the maximum number of iterations to determine when to end the simulation, in other words, the condition that is reached first. The Use Initial Flow from VUMA allows the user to reuse the previously calculated flow, reducing the number of iterations required for the simulation. Solver status errors will be indicated by a red cross, warnings will be indicated by a yellow triangle, and success will be indicated by a green checkmark in the leftmost block of the status bar area. To view the status, click on this block. This will open an error locator window with information about the simulation, including problems encountered. This window can also be accessed by selecting in the menu, Solve, Solution Errors and Warnings. Some of the common solver errors include unrealistically high temperatures. This can happen if there is a heat source in a branch with very low airflow. Extreme pressure drops. This can happen if there is a high quantity of air being forced through a restriction without any alternative path. Global errors. This can happen if the model is badly ventilated and cannot converge. Warnings can be customized using the Customize Warnings button in the Solver dashboard window. This window allows you to show or hide warnings, and for some, edit its tolerance. Branches or nodes with errors or warnings will have a blinking effect. To suppress this effect, you can opt to stop the highlighting of errors by unchecking the option under the Solve menu item. Here, you can also reset all node values back to the global default values. To use this option, click on the Solve, Clear and Reset All Values menu item. This is useful if you want to reset the node temperatures to the default value before restarting the simulation. Please note that if you add fans or fixed flows in series, there should be a leakage branch between the fans to allow for some air to be removed or added for the flow equations to balance. Another option is to configure the fan as multiple fans in a series. VUMA has several useful features to help you troubleshoot your model. One of these features is the recirculation check. This feature can be used to identify any areas of your model where air is recirculating. Recirculation can lead to several problems, such as higher temperatures and longer blast fume clearance times. To check for recirculation, go to the Solve menu and then click on the Highlight Recirculation button. This will open a window that lists all the recirculating areas in your model. You can click on a row to zoom into that area of the model. You can also uncheck the Unconnected Warning checkbox to not have VUMA prompt you about unconnected branches prior to solving. Secondary meshes are defined as a subset of connected branches that do not contain a path to the start node. Secondary meshes are not used in the solution, so they need to be either properly connected or excluded before you can solve the model. Fix reverse flows. This option will set the flow direction of all the branches according to the last solution. Remember to resolve the model after making any changes to the flow directions. This concludes the 30-minute basic training video for VUMA-network. If you wish for us to create a new video on a specific topic, please leave a comment below or drop us a mail at info@vuma3d.com. Happy modeling!